Before we leave integration by parts behind, we want to do the last topic, which is definite integration by parts. All right, so we want to evaluate the following integral using integration by parts. We're going to do the natural log of x dx. And I know what you're thinking. There's no multiplication there. That's true. However, we can still make integration by parts work, I promise. Because when you think about it, we don't have an integral for the natural log of x. We know the integral of 1 over x is natural log of x, but we don't have an integral for it. So we have u, du, dv, and v. Now u would be the natural log of x because I know what the derivative of that is, and I also remember Lipit, and in logarithms was right at the front. So I would choose u to be the natural log of x. And then du would be 1 over x dx. So then what's left over for dv, you're asking? Well, dx, right? That's dv. So dx, and the integral of dx with respect to x would be x, right? You just take the antiderivative of, if you like, you can think of it as 1, right? So the antiderivative of 1 is x. Okay, so now when I rewrite this with integration by parts, I would rewrite it as uv. So that would be the natural log of x times x. And I'm going to take that from 1 to e squared. Those are my x values. Minus, and I'm going to have an integral from 1 to e squared of v du. So let's see, v, which was x, and du, which is 1 over x dx. Right, so there's the v, and there's the du. Okay, so this is x natural log of x. I'm going to take that from 1 to e squared minus, okay, over here, x times 1 over x is just 1. So I'm going to take the integral from 1 to e squared of 1 dx. Now, if they end up being very different, you can always do each of these separately, but my limits of integration are actually the same numbers, so I'm going to keep going. And this is x natural log of x minus, and then this integral is x. And then all of this is from 1 to e squared. Right? Where this piece right here is forming that, and this piece right here is that piece. Right? So I kind of put them together. I mushed them. You didn't technically have to, but it's just easier. Okay, so then that means that I want e squared to go in. So it'll be e squared natural log of e squared minus e squared. Right, so there's e squared in there, minus, and then 1 natural log of 1 minus 1. So here is the e squared piece, and here's the 1 piece. Now the natural log of 1 is actually 0. So this piece turns into 0. So it's 0, take away 1. So negative minus 1 is plus 1. And then up here, the natural log of e squared, well, natural log and e are inverse functions of each other. So this is just 2. So that means that I have 2 times e squared minus an e squared minus a negative 1. So that would be, these two are like terms, e squared plus 1. And I don't know if you caught it, but we actually found out something kind of intriguing as we did this. We found that the integral of natural log, so if I take the integral of natural log, which is right here, forget about the numbers, forget about the definite integral portion of it, and look at what happens right here, which is the other reason I pushed them together. We learned that there's a formula for it. So the integral of natural log is actually x natural log of x minus x plus c. And that's a new formula that we didn't know before. And then we proved that it exists with integration by parts. I'm going to even highlight that one. That's a nice one to know. The power of integration by parts was able to provide that for us.